In today's lesson, we are going to continue to look at linear relationships. We're going to focus a bit more on connecting the representations of an equation and a table and going through between the different forms. So as a little bit of a review, Riley and Charlie both got their first jobs cutting grass. Riley makes $5 per hour. Charlie makes $4 per hour, but his client gives him a $3 tip every shift for doing their lawn first. Draw a representation to show the total earnings for each job using the template that's been started. So we are going to be kind of creating a visual pattern for this scenario. Riley makes $4 or $5 an hour. So on a shift, if it's $1 hour, they make $5. 2 hours would be $10 or 10 circles. $3 would be 15. And 4 hours would be 20. So that is our visual pattern roughly drawn out. Now if we look at the next one for Charlie, they make $3 as a tip and then $4 per hour. So at 2 hours, they still have their $3 tip, $4 from the first hour, and $4 from the second. For hour 3, $3 tip, and $4 per hour for the first 2 hours, and then another $3 or $4 for the third hour. And same thing for 4 hours. We got the $4 per 4 hours, and then we have the $3 tip. So is anything that we notice about these two visual patterns? Now there are a couple things that you might be able to come up with. So you might be able to come up with something like they're increasing at a consistent amount. Right, so they're both increasing by a constant or a consistent amount. You could say that Riley increases faster. And you could say another option, you could say Charlie starts off higher. Or you could mention something about a constant or that $3 tip. So again, different things that you could have. Again, just kind of getting into the idea of just noticing things about the different patterns and how they differ or how they're similar. Now what we're going to do is we're going to take those two situations and turn it into a table of values. So again, going back, just so we can see kind of our pattern, again, Riley was $5 an hour. So that means at 1 hour, they had $5, 2 hours, 10, 3 hours, 15, 4 hours, 20. For Charlie, it was $3 plus a $3 tip plus $4 per hour. So that's $7. At 2 hours, it would be 11. At 3 hours, it would be 15. And at 4 hours, it would be 19. So those are our two table of values. And again, we've done this before. As a review again, for all linear relationships, when we're coming up with the rule, generally speaking, we want it in the form y equals mx plus b. M is the multiplier, or we know it as the slope. So multiplier or slope, rate of change. B is the constant, or y-intercept, or starting value. And now we have definitions for our x and our y value. X is the independent variable, or in our example, hours worked, and y is the dependent variable, or total earnings. Again, when we've talked about our table, we've mentioned that the first column is usually y, or x, the second column is usually y. You could also reason through it. If it's an independent variable, that means that it doesn't depend or it isn't affected by the other one. So if we look at our scenario, the earnings or the amount we earned is dependent on the number of hours. The number of hours we worked isn't affected by how much we've earned. It's the other way around. How much we earn is affected by how much we work. So let's write an equation for each linear or each situation, and then we're going to graph it. So again, Riley's situation, the multiplier was 5 because that's what we were increasing by every hour. And our constant is 0. We don't have a constant in this case. We don't have a starting value, or our starting value is 0. For Charlie, has a multiplier of 4 because we're increasing by 4 every time, and we have a constant of 3 for that $3 tip that we've earned. Now what we want to do is we want to graph these two situations. So we're going to have our y-axis and our x-axis. We have 0 in the bottom. For our x-axis, our scale can be relatively straightforward. And for our y-axis, our values, let's say they are every box is 2. We have 4, 8, 12, 16, 20, 24, 28. Again, it is helpful to have titles. So the y-axis is the dollar amount or the earnings, and the x-axis is our hours. So if I go through and I graph Riley's, they start off at 0. At 1 hour, it's $5. At 2 hours, it's 10. At 3, it's 15. And at 4, it's 20. And I could continue on. 5 would be 25. And 6 would be 30. But again, I only really need to graph the first 4 because that's all my table has. As well, I know, or I should know, that when I draw a line through them, it's going to be a straight line. So there we have Riley. For Charlie, Charlie starts off at $3 and increases by 4. So starts off at 3, and at 1 hour, they earn $7. At 2 hours, they've earned 11. At 3 hours, they've earned 15. 4 is 19. 5 is 23. And I could continue again because I know what the pattern is, or I can just draw a nice straight line through all my points to represent Charlie's. So now I have my two lines to represent the relationships, and how is M represented in the graph? Again, we've talked about it, the different terms, but M is representing the slope or the steepness. How is B from our equation represented in the graph? Again, as a review, B is representing our starting value, or in other terms, our y-intercept. So again, different notation, or different terms for the same notation. So again, that was a bit of a review of what we've already done. Now what we're going to be doing is looking at the connection between an equation and a table of values. So for each linear relation equation, complete the table of values. So we're given an equation and we're given the x values, or the independent variable, or values for that, and we want to find out what would y equal, or what would be the dependent variable. So in this case, what we're going to be doing, and we've done similar things before, we're going to substitute values for x into the equation. So if I look at the equation 1, y equals 5x. If I want to find out what does the y value equal when x is 0, I'm going to substitute 0 in for x. So 5 times 0, and I get 0. For the next one, y equals 5 times 1, which is 5. Y equals 5 times 2, which is 10, and I continue the same pattern, 15, 20, for the remaining values. Now you might be able to recognize the pattern, which is okay. We can see that we're increasing by 5 every time. Now for equation 2, going from the equation to the table of values, we could go through and do the same thing, substitute the value in, y equals 10 times 0 plus 5, and we end up with 5. But hopefully we're starting to see a little bit of a connection between the table of values and the equation. Again, recognizing that the 5 is the value when x equals 0. So we do have that terminology in one of our previous notes, that the 5 represents when x equals 0. The multiplier tells us what we're increasing by every position. So when I go from 5 at position 0 to position 1, I should be increasing by 10. And I should be getting 15. Now I can double check this. Y equals 10 times 1 plus 5. Oh, I get 15. So that does work. So the next position, I'm going to increase by 10 again, increase by 10 again, 25, 30, oops, it should be 35, and 45. So we do start to see a little bit of a connection between the equation and the table of values. Now the same thing was in the previous one. We were increasing by 5 every time, which was our multiplier. So again, we do have these connections between the equation and the table of values, or quicker ways to do it by recognizing what the pattern is. If we look at number 3, if we look for our constant is 2. So that's a good indicator that when x is 0, y is 2. However, in this case, our table of values doesn't include the 0 or when x equals 0. So that doesn't really help us right now. So we still have to go back. Y equals 2 plus 3 times 5. And we get 17. Now the multiplier is helpful here, because I can now say, well, I'm going from one position to the next. I'm going from position 5 to position 6. So my y value, or you could say the number of tiles, should increase by 3. So in this case, I've increased by 3. So now we're at 20. Increase by 3 again. We're at 23, and 26, and 29. So we continue that pattern of adding 3 for every position number. So now I would like you to pause the video and try to go through the next 3 on your own. You can use kind of the quick way, or you can use what we've done in terms of looking at the connection between the equation and the table of values. So I recommend you pause the video and try doing the last 3 on your own. So looking at our 3 tables, this is what you should have. Again, we may have been able to work through it by looking at the connection between them. But again, you can see what the table of values should be. Easiest way is to basically just plug in your values into the equation for x and solve for y. That's the easiest way, kind of avoids any confusion or any recognition of how the equation connects to the table. The next part now we're going to go from the table of values to an equation. So this is where recognizing those kind of patterns is helpful, because we do need to then put it into a rule. Two key things to remember: the m value, or the multiplier, is the change in y when x increases by 1, or basically every time I change by a position of 1, how much am I adding on? And then the b value, the constant or y-intercept, is the value of y when x equals 0. So for our first example, the easiest thing to do is look for that constant, because I can look for when x equals 0. I can see x equals 0 here. I see y equals 4, so that's going to be my constant. To figure out now the multiplier, I need to first see, are my x values increasing by 1? Am I looking at a change of 1, or am I increasing by 1 position? So I can see I'm adding 1 from 0 to 1, 0 to 2 is an increase of 1, 2 to 3 is an increase of 1, 3 to 4 is an increase of 1. If I look at my y values now, what do the y values change by? Well, 4 to 9 is plus 5. 9 to 4 is plus 5, 9 to 14. 14 to 19 is plus 5. 19 to 24 is plus 5 as well. So that tells me that because every position I'm adding 5, my multiplier is going to be 5. So my equation then, or the rule, is y equals 5x plus 4. For number 2, same idea. I'm looking for when x equals 0. I see it here. So my constant in this case would be plus 0. Now I need to see, are my y values, or x values, increasing by 1? Am I seeing every position? Well, 0 to 1 is an increase of 1. 0 to 2 is an increase, 1 to 2 is an increase of 1. 2 to 3, and 3 to 4. So I'm seeing every position, so I just need to look for, what are my y values changing by? Well, plus 3, plus 3, plus 3, plus 3. So for every position, I'm adding 3 tiles, you could say. So my rule, or my multiplier, will be 3. So it would be 3x plus the constant of 0, or just 3x. Now, for number 3 is a little bit trickier, because we don't see x equals 0. So we can't really start with our constant right now. What we can do is we can look and see, is my multiplier visible? And by that I mean, are my x values increasing by 1? So from 1 to 2 to 3 to 4 to 5, they are increasing by 1. So let's see what my y values are changing by, or basically how many tiles am I adding every position. In this case, from 10 to 12 is 2, 12 to 14 is 2, 14 to 16 is 2, and 16 to 18 is 2. So this means I'm adding 2 tiles every time, so that tells me my multiplier is 2x. We still need to figure out what our constant is. So because we don't see position 0 here when x equals 0, we might not be able to find it right away, but we should be able to work backwards to find position 0. So if I work backwards, I'm taking away 1 in my position, and if I reverse my pattern, I'm taking away 2 tiles. So from 10, that would leave me with 8. I now see when x is 0, y is 8, so my constant, or the b value, is going to be 8. So the rule would be y equals 2x plus 8. Again, for the last couple ones, I want you to try and practice this on your own. So I recommend that you pause the video and try to come up with the rules for these three tables. So for your last three tables, these are the rules that you should have. Now, 4 might have been a little bit difficult, but again, we're still looking for when x equals 0 for our constant. We see that it's 25. We see that the x values are changing by 1. The only difference here is now we're decreasing. So we're decreasing by 4 every time instead of increasing. Doesn't change what our multiplier is. What we're changing by is still our multiplier, so it's still the minus 4. The only difference now is that we have a negative. For number 5, again, we can clearly see when x is 0, our y is 1, so that's our constant. Here, our x values are not increasing by 1, they're increasing by 2. So I increase 2 positions, I increase by 8. So you might have put 8 down as our multiplier, however, we're not increasing by 8 every position. We're increasing by 8 every 2 positions. 8 tiles for every 2 positions. But we want it for every 1 position. So you could argue, well, in between, if I go in between to position 3, if I'm going 8 every 2, then that should mean that I'm going 4 every 1, which would then be 13, and so on. So that means that every position I'm increasing by 4. So if you know how much you're increasing by for every 2 positions, hopefully you can figure out how much you're increasing by for every 1 position. And then you get an increase or a multiplier of 4. For 6, because our x values are increasing by 1 every time, I don't really need to worry too much about finding my multiplier. I just look at what the y values are changing by. In this case, it's increasing by 5 every time. The difficult part now is figuring out the constant. So we could work our way back all the way back to position 0. So we'd be decreasing by 5 every time. You could also reason through, well, if I'm decreasing by 5 to get back to position 0, then I'm going to be decreasing or reversing my pattern by 5 times. 5 times 5 is 25, so if I remove 25 tiles, that will take me back to the position 0, which would give me a value of 7, and now I can see that my constant would have to be 7. You don't have to go through and do it in exactly one step. You could go back to position 4, then 3, then 2, then 1, and get your answer, and it will still be 7. So again, we have our different rules for these tables. Next, what we're going to do is come up with the same thing or do the same thing, but now try to fill in some blanks as well. So we're going to try to come up with our rule and fill in the blanks. So again, we'll work through a couple, and I'll leave you with some to try on your own. So determine the rule for the linear relationship. So for number 1, again, number 1 is nice because we can clearly see the constant, which would be plus 1. Now we have to figure out what would I need to add every time so that when I get to 25, or when I get to position 4, I'm at 25. Now you could kind of work backwards from our rule and say, okay, well, if I take away 25 or take away 1 from 25, if I take away that constant, that means I have 24 tiles. You could reason through, well, 24 tiles over 4 positions would equal 6. So that means that my multiplier in this case would be 6. So and we can go back and test. 1 plus 6 is 7. 7 plus 6 is 13. 13 plus 6 is 19. And then 19 plus 6 is 25. So there's different ways you can reason through it. You could use trial and error, but you should find that your rule will be y equals 6x plus 1. For number 2, this one is again also trickier because we're given position 1, 7, and we're given that 35 at a certain position. So we only have 2 values to try to work out. You could do some reasoning through, and we will talk a bit more about this later on. So these are really just more challenge questions. From position 1 to position 7, I'm increasing by 6. And from position 1, or at 1 tile to 25, I'm increasing by 24. So that means 24 tiles for 6 positions, which would mean 4 tiles per position. So if it's 4 tiles per position, that tells me my multiplier of 4. And now I can start to reason through this a bit. If I know my multiplier is 4, if I look at, say, position 1, y equals 4 times 1 plus something, or you could say plus b, has to equal 1. So 1 equals 4 plus b. Solving equations tells me then that if I subtract 4 from both sides, I get negative 3 equals b. So that tells me, or we can also again work backwards and say if I go backwards 1 position to 0, go backwards 1 position and take away 4, I'm at negative 3. So in different ways we can reason through it to get a constant of minus 3. And lastly, for number 3, because then we'll let you try the remaining 3 on your own, we have at 5, we have 10, and at 7, we have 6. So again, we're looking at the 2 patterns or 2 positions that we know. 5 to 7 is a change of 2 positions. From 10 to 6, we've decreased by 4. So if I'm decreasing by 4, so minus 4 tiles for 2 positions, that means we're minusing 2 tiles per position. So that is going to tell me my multiplier, because what I'm changing by every position, which is minus 2. And now we need to figure out our constant. We could reason through it if I'm working backwards from 5 to 0. That's decreasing by 5 tiles, or 5 positions. So for tiles, if I reverse the pattern, instead of decreasing by 4, I'm going to be adding 4. But I'm going to be doing that 5 times. So I'm going to be actually adding 20 tiles back onto my pattern, which gives me 30 tiles. Again, you could go through and reverse the pattern for position 4, then 3, then 2, then 1, and then 0. Either way, you do get to the end, and you get plus 30. So again, these ones are trickier, but I want you to try to challenge yourself and try to go through numbers 4, 5, and 6. So for the last 3 examples, have the rules written out. Number 4, you should be able to reason through in a similar manner to what we've done before. 5 and 6 are going to be a lot trickier. They do require some more knowledge that we are going to look at in the later lessons. But these are, again, more challenges for yourself if you found the other ones a little bit easier. So again, I do challenge you to kind of attempt these, or hopefully you did attempt them. And then we will, again, look at a lesson later on that tells us how to, or gives us more tools to actually go through and figure this out. So again, the main thing though is making the connection between the equation and the tables like we've done, and being able to look at some tables of values, the easier ones, and come up with the equation or the rule. And again, you can challenge yourself to hopefully try to figure out some challenging ones, but don't worry if you couldn't, because we will look at or learn some tricks to figure that out.